Bright Tuty. Every student matters.
Determine which of the following polynomials has x plus 1 a factor. If a polynomial, let us say these polynomials are p of x, okay. So if a polynomial has x plus 1 as its factor, let us say p of x has got x plus 1 as its factor and something else also, x plus 1 into something. So if it is a factor, if I put this factor equal to 0, this entire expression will become 0. That when will this factor be equal to 0? At x equal to negative 1. So the conclusion is, if I put x equal to negative 1 in this polynomial and it becomes 0, then I will say x plus 1 is a factor of this. Okay. So let us look at p of negative 1 in this. It will give you minus 1 cube, that is minus 1, plus 1, minus 1, plus 1. So it is equal to 0. Hence x plus 1 is a factor. Look at this one, p of minus 1. I am considering all these as p of x, right? P of x doesn't mean that all of them are same, right? This is a separate question, this is a separate question. So what you need to do is, you need to consider that this is equal to p of x in every question. P of minus 1 equal to minus 1 raised to 4th power 1, minus 1 raised to 3rd power minus 1, minus 1 raised to 2nd power plus 1, minus 1 plus 1. So this is 1. Hence x plus 1 is not a factor of this polynomial, this second part, right? In the third part, p of negative 1, 1 minus 3 plus 3 minus 1 plus 1. So this got cancelled, but it is not equal to 0. Hence x plus 1 is not a factor, right? So you can write this statement, let the polynomial be p of x. Now p of minus 1 is not equal to 0. Hence as per the factor theorem, I can say x plus 1 is not a factor of this given polynomial p of x. Okay. So these are the statements that you need to write. In this, p of negative 1 is equal to minus 1, minus, and this is negative 1. So minus plus 2 plus root 2 and then plus root 2. Obviously this will not be equal to 0, right? These cannot be cancelled, okay? So this will not be equal to 0. Hence x plus 1 is not a factor of this polynomial here, alright? Use the factor theorem to determine whether g of x is a factor of p of x in the following cases. What is g of x? G of x is x plus 1. If it is a factor, then if I put x plus 1 equal to 0, then the entire expression will become 0. So x equal to minus 1 should make this entire expression 0 for x plus 1 to be the factor. So if I place p of minus 1, if I place x equal to minus 1, it will give me minus 2 plus 1 minus plus, so minus plus 2 minus 1. These are cancelled. Hence g of x is a factor of p of x. Okay. In this, g of x is x plus 2. When g of x or x plus 2 is equal to 0, it means x should be equal to minus 2, and if this factor is 0, the entire expression should become 0 if it is a factor. So if I put x equal to minus 2 in this and it becomes 0, then we will say this is a factor, otherwise it is not. So p of minus 2, minus 8 plus 12 minus 6 plus 1, right? So this is minus 14, this is plus 13. So it is equal to minus 1. Hence, in this case, g of x is not a factor of p of x, right? Similarly, in this one, If I put x minus 3 equal to 0, it will give me x equal to 3. Now I'll check whether this becomes 0 at x equal to 3 or not. So p of 3 is 3 cubed 27, 3 square is 9, 9 into 4 is 36, so minus 36 plus 3 plus 6, 27 plus 9 is 36, 36 minus 36 is 0. So p of 3 is 0, hence g of x is a factor of p of x. Okay, and you can also say by factor theorem. All right. Find value of k if x minus 1 is a factor of p of x. Now x minus 1 is given as factor, is a factor. So p of 1 should be 0, right? So p of 1, that is 1 square plus 1 plus k, is equal to 0. Why? We have already stated, if x minus 1 is a factor, then p of 1 is equal to 0 as per the factor theorem. Hence this expression is 0. 1 plus 1 plus k is equal to 0. So it will give me k equal to negative 2. In this, if I put p of 1, that is 2 into 1 square plus k into 1 plus root 2 equal to 0, this will give me k equal to minus 2 minus root 2. And in this, p of 1, that is k minus root 2 plus 1 is equal to 0. So k is equal to root 2 minus 1. Similarly, p of 1 is equal to k minus 3 plus k, and it is equal to 0. Okay, so 2k minus 3 is 0, hence k is equal to 3 by 2, and this is your answer. Right, this was a simple application of factor theorem, that if this is a factor, then p of 1 has to be 0. Now put p of 1 equal to 0 in each of these cases and you will get values of k. Now we need to factorize these. So these are quadratic polynomials, hence I can split the middle terms easily and factorize these. Otherwise, you can also use factor theorem where you need to randomly put the factors of the constant term divided by the coefficient of x square, right? Because to use factor theorem, I need to write this as, if I take 12 as common, x square minus 7 by 12x plus 1 by 12, right? Now I need to see factors of this, okay, and start putting in place of x. If it becomes 0, the entire expression, then I'll say that it is the 0 of this polynomial. This method may be little more cumbersome than compared to our middle term splitting method. So I'll go by middle term splitting method here because it is not specifically mentioned to go by factor theorem. So to split middle term, I need to see this product 12x square. Now how should I split minus 7x so that I get minus, how should I split minus 7x so that I get 12x square as the product of those two factors? Minus 7x. If I write it as minus 4x minus 3x, their product is 12x square and their sum is minus 7x. This is the crux of middle term splitting. So I'll write it as 12x square minus 4x minus 3x plus 1. So 4x if I take as common, I'll have 3x minus 1 here, minus 1, 3x minus 1. So this will give me 4x minus 1 into 3x minus 1, and these are the factors of this quadratic polynomial. In this, I need to produce 6x square by splitting 7x. So 7 and I need to produce 6. So 6 and 1. 7 can be split as 6 plus 1. Their product is 6, right? And their sum is 7. So this can be written as 2x square plus 6x plus x plus 3. If I take 2x common, x plus 3 plus 1 common x plus 3. So this is 2x plus 1 into x plus 3, and these are the factors. Similarly, minus 36x square. So 5 has to be split in a way that the two factors that we split 5 into will give me a product of 36. So I can see 9 and 4 because their difference is 5 and their product is 36. So I'll write 5 as difference of 9 and 4. How? 6x square plus 9x minus 4x minus 6. So I'll say I'll take 3x as common, 2x plus 3 minus 2 common, 2x plus 3. So the factors are 3x minus 2 and 2x plus 3. These are the factors. In this one it is pretty simple because 4 into 3 is 12, right? So I need to produce 12 and I've got 1 here as coefficient of x. So 4 and 3, 3x square minus 4x plus 3x minus 4. This is the split. Their sum is minus x and their product is minus 12x square. So if I take x common, 3x minus 4 plus 1, 3x minus 4. So this will give me x plus 1, 3x minus 4 as the factors. Okay. So these were the factors of given quadratic polynomials. Now we are given cubic polynomials. In case of cubic polynomials, we will use our hit and trial method. That is, we will look for the factors of this constant term and put each and every factor in the given polynomial and see for which factor or for which number this becomes 0. That will be the 0 of this polynomial and that will give me one factor. Okay, so the first step is to see the factors of this constant. 2 has got factors like plus minus 1, plus minus 2. So if I put 1 here, let us say it is p of x, okay. So p of 1 will be equal to 1 minus 2 minus 1 plus 2. So it is 0. Hence x minus 1 is a factor. Okay. Now if x minus 1 is a factor, I need to write this in such a form so that I can take out x minus 1 and I'll get a quadratic polynomial inside. So if I write it as x cube minus x square minus x square minus x plus 2, this will give me x square into x minus 1. I can write it as plus x minus 2x, right? So if I take minus x common from it, I'll have x minus 1, and if I take minus 2 common, x minus 1, right? Now this expression can be written as x minus 1 into x square minus x minus 2. This is a quadratic polynomial which can be easily factorized using middle term splitting. So let me factorize this first question for you. X minus 1 into, this can be written as x square minus 2x plus x minus 2. So x minus 1, this will give me x into x minus 2. So x minus 1, x plus 1, x minus 2. These are the factors of this cubic polynomial. Okay, now we have got another cubic polynomial, right? We need to factorize this. So first thing, I look for a linear factor of it. How? By looking at the factors of constant, that is 5, right? So it has got plus minus 1, plus minus 5 as its factors. So let me check 1 and minus 1 first. So p, let it be equal to p of x. So p of 1 is equal to 1 minus 3 minus 9 minus 5. So it is not equal to 0, right? Hence I can say x minus 1 is not a factor. Is not a factor. Now I'll check p of negative 1. See, minus 1, minus 3, plus 9, minus 5. Yes, this is equal to 0. Hence x plus 1 is a factor. Now that I have got a linear factor, I will divide this cubic polynomial by this linear factor and I will get a quadratic polynomial as its quotient. Okay. So let me divide. X cube minus 3x square minus 9x minus 5 when divided by x plus 1 will give me x square here. So x cube plus x square, this will cancel out, minus 4x square minus 9x. So minus 4x square minus 4x. So this will cancel out, minus 5x minus 5. So if I multiply this by minus 5, it will give me minus 5x minus 5. Hence this is the quadratic polynomial that we were looking for. What I mean is that p of x is equal to, this was one of the factors, so x plus 1 into, this is another factor which is quadratic polynomial. And the quadratic polynomial we are comfortable in splitting the middle term. So x plus 1 into, this will be x square minus 5x plus x minus 5, x plus 1, x common, x minus 5 plus 1, x minus 5. Now you can see the factors, x plus 1 into x plus 1 into x minus 5. So this is the factorization. Two of the factors can be same also. So this is your answer. Similarly, we will factorize this one. I look at factors of 20 which are plus minus 1, plus minus 2. Why do I take plus minus? Because these are also factors, right? So you can consider plus and minus also. So plus minus 3 is not a factor, plus minus 4 is a factor, plus minus 5 is a factor, right? So let us check with 1. 1 if I put, it will be sum of coefficients, right? Because x, in place of x if I put 1, it will give me sum of coefficients, that is, for example in this case, if I put x equal to 1, this will give me 1 plus 13 plus 32 plus 20, which will not be equal to 0, right? This you could have visualized without even writing this step, okay? So you directly start with p of negative 1, because something negative when you put in place of x can make this expression 0, something positive cannot make it 0. So p of minus 1, minus 1 plus 13 minus 32 plus 20. So 20 plus 13 is 33, 33 minus 1 is 32, 32 minus 32 is 0. So by using factor theorem we can say x plus 1 is a factor, and if x plus 1 is a factor of this, we can divide this cubic, x cube plus 13 x square plus 32x plus 20 by x plus 1, right? And it will divide it completely, leaving me with a quadratic polynomial as quotient. So x square, x cube plus x square here, minus minus, so this will give me 12x square plus 32x. Now I will multiply it with 12x, right? So this will give me 12x square plus 12x. When I subtract, I will get 20x plus 20 here. So I will multiply it with 20 and it will completely divide it. So I will get 0 as my remainder. Now this is the quadratic polynomial that we were looking for. So p of x is equal to x plus 1 into x square plus 12x plus 20. Okay, now splitting the middle term is pretty easy in this case, right? 12 can be split into 10 and 2. So x square plus 10x plus 2x plus 20, it will be equal to x plus 1. If I take x as common, I will have x plus 10. If I take plus 2 as common, I will have x plus 10 inside. So x plus 2 and x plus 10 are going to be the factors of this quadratic polynomial. Hence this is the factorization of given polynomial p of x. Okay. In the last question, let us say this is p of y equals this. Okay. Now this can also be written as, if I take 2 as common, this will be y cube plus 1 by 2 y square minus y minus 1 by 2. Okay. Now I will be looking for factors of this minus 1 by 2, right? So let us visualize what factor will make it 0. If I put 1 here, it will give me 2 plus 1, 3, right. So if I put p of 1, so it will give me 2 plus 1 minus 2 minus 1, 0, right. Hence, I can say y minus 1 is a factor of it, right, because 1 is a factor of every number. So I always start with putting the variable equal to 1. In this case, it worked. So I've got a linear factor. Now the task is to find the remaining quadratic expression. So I'll divide this cubic, 2y cube plus y square minus 2y minus 1 divided by y minus 1. Okay. So the first thing I'll multiply with 2y square. It will give me 2y cube minus 2y square. When I subtract, this will cancel out and this will give me 3y square minus 2y. Okay. Now I multiply with 3y. Okay. So 3y square minus 3y. When I subtract, this will cancel out and this will give me y and this minus 1 here. Now plus 1. So y minus 1 and it will completely cancel out. So the given polynomial p of y is equal to y minus 1 into this quadratic expression, that is 2y square plus 3y plus 1. Okay, which we will factorize through middle term splitting. Okay, let me do it here itself. So it will be y minus 1 into, this can be written as 2y square plus 2y plus y plus 1. So it is y minus 1 into, if you take 2y as common, it will give you y plus 1 inside. Let me show it to you. And if you take 1 as common, it will be y plus 1 inside. So y minus 1, 2y plus 1 into y plus 1. This is the factorization of the given cubic polynomial, right? So in case of cubic polynomials, the first target is to find a linear factor, right? How do we find that? By looking at the constant term and looking at this factor. So first step is to make the coefficient of x cube as 1. Then look for the constant. The factors of this constant will give you one of the factors, that is a linear factor. Now once you got the linear factor, you divide the given cubic polynomial by that linear factor and you will get a quadratic polynomial. Now that quadratic polynomial can be factorized using middle term splitting or by factor theorem also if you find it easier. So that is how we will go about cubic polynomials. Okay. Alright. So this was about this lecture. I hope the factorization of cubic polynomials and factor theorem in general is clear to you. Thank you.